Alright guys, today just doing a really quick verification of finding weight two different ways. We've been talking about finding weight by taking mass times acceleration due to gravity on the Earth. And then we've recently learned about Newton's universal law of gravitation. So number one says, how much does a 100 kilogram bag of hair weigh on the surface of the Earth? And we're going to solve it two different ways. So old school way, weight equals mass times acceleration due to gravity. So we go 100 kilograms times 9.8 meters per second squared. We come up with 980 kilogram meters per second squared, which we learned earlier is the same thing as a Newton. So really simple, we weigh 980 newtons. If we kick over here using Newton's universal law of gravitation, that gives us the force due to gravity. And guys, we all know, we've learned already that force due to gravity and weight are the same exact thing. And so if we take force due to gravity equals the universal gravitation constant, G, times the mass of your object, times the mass of the other object, which in this case is the Earth, divided by the radius of the Earth squared, we can come up with our force due to gravity and our weight. So guys, as you recall, Newton's universal law of gravitation, Newton's universal gravitation constant, G, was determined, we read in the book, determined by the machine that Mitchell made and then Cavendish later used to kind of measure that. Once we had this value, good things started to happen as far as figuring out the size of our solar system and all the masses of the planets in it. But that is a constant that stays the same no matter where you go in the universe. It's called the universal gravitation constant, represented by capital G. We take that, multiply it times the mass of our bag of hair, 100, times the mass of the Earth, which is 5.98 times 10 to the 24th kilograms, can be found in the front of your book. And then we divide that by the radius of the Earth squared. And guys, this number is a little bit variable, the 6.38. Because the Earth is not perfectly spherical, when it spins, it kind of flattens itself out. So this isn't a number that is perfectly constant, but this is the one that you find in your book. That's the one that we'll use in the class. So if we take that radius and we square it, and guys, if anybody makes any mistake on the test, it's usually because they forget to square that. So please note that that is squared. When we take all that, we plug it into the calculator, it spits out a weight or a force due to gravity of 980.29 newtons, which isn't exactly the same as this, but guys, this number right here is a number that we use that's rounded a little bit, and so therefore that kind of accounts for the discrepancy. But you can basically see that either way you go about it, that 100 kilogram bag of hair is going to weigh about 980 newtons on the surface of the Earth. If we went somewhere else, like the moon, the acceleration due to gravity is going to diminish. If we go to Jupiter, it would get bigger, and so these weights would change. And like we talked about in class, remember, guys, weight is something that changes with location. It also is measured using a scale, not a balance. And if we go to mass, that doesn't change no matter where you go, and it's measured with a balance instead of a scale. So anyway, kind of a verification of Newton's universal law of gravitation.